All right, kiddos. Hey, the next thing we're going to talk about is inverses of a function or relation. In case we're talking about relations, we're trying to identify if it is a function or not. Okay, so a quick review. If all my x values are different, then this is automatically a function. So this relation is listed as a function. Hopefully that's a review. So I'm going to take this function here, relation s, and first thing I'll do is I list my ordered pairs, right? This is a, b, and what do I have going on over here? Well, this is now b, a, right? 0, -1 turned into a -1, 0, 2, 0 turned into 0, 2. They just get flip-flopped, all right? And then what we can do is check and see if the inverse is a function. They're all different, so that is as well. This is what we use as our most basic idea of how to test to see if something is a function. But you're in Algebra 2, so we're not going to use that. But if you get stuck or you have somebody else asking you how that works, then you give, all right, well, this is the basics and this is how it works. Because that's what we gave you. All right, some art examples here. I don't know. Do you guys even know like film for like cameras? I don't know. Like things are so different. It's 2022 and I'm shooting this video. It could be like 2042 for all I know. Right. Well, there used to be film in a camera and you would get negatives and then you get it, you take it over to like CVS or someplace and they would develop it for you. Right? And you get this picture in black and white, or here it is, the negative in color, and here it is. Right? So trying to use that idea, everything is backwards. Notice all the really dark areas here are super light here. So inverse is kind of flip-flopping those things. Right? If you're really into art, right? Here's another one, right? It started with all the ink on the page. It's called etching. Yeah, I'm a big art guy. You can tell I draw a lot of pictures. So it's called etching, and you actually take the ink off. So, you know, some of these lighter areas here, right? That's where you've scratched off all the ink, and it makes you think backwards, and that's kind of what we're doing with inverses. We want to flip some things around. All right, so here's what we got going on. Domains, ranges, they kind of flip-flop. So we notice in our first one, in relation R, this is definitely a function. All my x values have one arrow coming out of them. Notice what happens in the inverse is now 1 has 1.2 and 1.4. So this is no longer, it is the inverse. I shouldn't cross that out. It is the inverse, but this is a relation, all right, versus this one is still a function. Okay, so it just helps show us that just because something is a function when we get started, the inverse is not always going to be. And one way we have testing that is a map here. We could have done ordered pairs, and eventually we'll deal with some of this. Oh, here it is. Here's that idea. AB turns into BA. That's the most basic way of testing to see if we have found ourselves an inverse. All right, so that was testing it, but here now I have an equation. So what do? So I got two things to do, right? First thing we do is I'm going to switch x and y. So first thing we do is I'm going to say this is x equals y squared minus 1. Like, hey, hold on, Mr. Toll, I thought you were switching them. Yeah, I am switching just the variables. Notice the x squared is now y squared. All right, step 2 now. Step 2 is to solve this thing for y. So I'm going to add 1 to both sides. X plus 1. You're like, oh man, we're going to get weird answers again. I'm like, yeah, we are. All right, we're not getting answers like 5. We're not getting answers like -2 or 2.5. Right? They're going to be kind of awkward. How do we get rid of the square? Come on, we're old hat at this. We got the square root. So the function, right, was x squared minus 1. Its inverse, y equals the square root of x plus 1. Right? That's going to be the inverse. And I can prove it if I plug some values in and I get the inverse points, right? AB goes into the original, I get BA out of the other one. Not something we have to do right now. I just want you to get this routine down. Okay, what's the inverse? Remember, the first thing is switch x and y. X equals y minus 4 squared plus 5. All right, now if I was going to write a note on this one, I would say when I'm doing inverse, don't ever FOIL. Right? Because I have one y in the problem right now. I want to make sure I keep having one y in this problem. I know how to get rid of that square if I can do the square root, but there's other stuff in the way. So let's get rid of the other stuff. Plus 5, I need a minus 5. So I have x minus 5 equals y minus 4 squared. We already talked about this. We're going to take the square root to get rid of that. Now the order matters, right? So the last thing I'm going to do, the very last thing I'm going to do is add 4, but it's after I took the square root. So I might have 4 added on to that. So my inverse should be y equals, I'll write it so it looks normal, x minus 5, and then plus 4. I left an obnoxious kind of amount of space there, but I want to make sure that this plus 4 is on the outside of that square root, right? Because that was the last thing that happened. If for some reason I had a bunch of stuff in there, if they were all supposed to be inside the square root, we would have done that earlier. Okay, so the order in which these things happen is really important to how we write it. All right, the next one, same thing, right? Do have an old question for you here. The domain and range of this square root function. Right? So remember, the square root function typically looks like this. So I would go with domain, x is greater than 0, the range, y is greater than 0. But this one has been moved. If it's -2, right, x minus 2 has to be greater than or equal to 0. X is greater than or equal to 2 by adding 2. That makes up my domain, because remember, this graph actually moves to the right too. The range hasn't moved up or down, right? There's nothing added or subtracted, so y is greater than or equal to 0, right? Because I'm focused in on this second graph right here. So it's going to go up from there. So we're going to be greater than or equal to that. Now, the next part has a different notation. It says find f to the negative first. What? Right. So using that notation just means find the inverse. Right? Did I make that dramatic enough? Dramatic. So how do we do that? Remember, f of x is the same thing as y. So I had y equals the square root of x minus 2. First thing, change it out. X equals the square root of y minus 2. Oh, everything's locked up by that square root. How do we get, to get rid of the square root, I'm going to square both sides. So now I have x squared equals y minus 2. We're going to add 2. So the inverse, notice I'm going to use that notation, inverse of x turns out to be x squared plus 2, as I lean right off the screen here. Don't worry, I'm okay. All right, so that's how we find our inverse. This is a notation, so I don't have to type the words find the inverse anymore. I can give you f of x and then say, okay, find f to the negative first of x, inverse. All right, we are in algebra 2, so we are going to prove by composition, right? That's when we take one function and we put it inside the other function, that they are inverses, because I can make a lot of things work even though they shouldn't, like, AB pairs to be BA, especially with zeros and ones, they can be very, very deceiving. So to prove in pure mathematics, I want to do a composition. So let's see what happens. This little box here is kind of important. It tells me that my end result should be just x, and it has to work, and it has to work both ways. So I can't just do one and say, oh, it works, so it must work the other way. Now, what I can do is if it doesn't work for one of them, right, if I get x plus 4 when I did it the first time, I wouldn't do the other one because it failed part of the test. All right, let's do this one. Let's find the inverse. It's got a fraction, so this is going to look a little bit weird, but you can do it. Okay. So it started off as y equals 1 over x minus 1. Okay. First thing is switch them. X equals 1 over y minus 1. The next thing I'm going to do is I'm going to put this over 1. So you realize we're really just going to cross multiply. Okay, next thing I want to make sure I do is do I want to, let's see. So I have x times y minus 1, right? That's right here, equals 1. All right, what are we solving for? We are solving for y, right? Remember, we switched them out. So I can distribute this or I can leave it out. I'm going to leave it out because if I put it in here, then I have to take it out. So I'm going to go ahead and divide by x. Right? That might change sometimes, so don't feel like there's just one way to do it. And if you distribute it already, that's okay. Y minus 1 equals 1 over x. I'm trying to get this y by itself. So I'm just going to add 1 to this and add 1. So there we go. So my inverse, notice I'm going back to my new inverse notation, 1 over x plus 1 is supposed to be the inverse of f of x, 1 over x minus 1. Right, now we have to prove it. Okay, how do we prove it? We have to plug one into the other one. Here we go. So I'm going to take my inverse, right? I'm going to take this and I'm going to put it right here, right here. So 1 over x plus 1 minus 1. All right, so I use these parentheses only because I wanted to show you where it went. But +1 and -1 become 0. So now I have 1 over x. That seems confusing because it's written vertically. Okay, so it's 1 divided by. So it's 1 divided by 1 over x. Hey kids, fun fact, what happens when you divide by a fraction? You multiply by its reciprocal? I love that answer. Here we go. You got x. All right, so that's good news because it means there's a good chance it's going to be the inverse. But the bad news is now I have to prove it by doing this the other way around. Sad face, right? No, that's good. That's good. It's good. All right, let's pick a color. So many colors on here. All right, let's go with the very vibrant orange. All right, so that means this time I'm going to take 1 over x minus 1. I'm going to plug it in right here. 1 over x minus 1. And then plus 1 after it. All right, now we just went through this whole thing. If I divide by a fraction, I multiply by its reciprocal. All right, so I know this might be a little bit fast, but what happens is this whole thing flips over. So I have x minus 1 plus 1. Because it divided by the fraction, all the ones going on here, it happens. All right. If you're not sure about that, ask me in class. If you're not sure about it online, write it out the way I had it vertically here. All right, now these parentheses don't mean anything. -1 plus 1 is 0, so I get x. They're inverses. We're so happy. All right, so we proved that they're inverses. Good stuff. All right, here's another one, the fraction. Since I see that I have to do some of these by using the inverse, I just want to make sure that we go through that one more time. Remember, I put in here already. This is y. That'll save us a little bit of space. Here we go. X equals 4 over y plus 2. I almost did it. Y plus 2. All right, over 1, cross multiply. X, y plus 2. Don't actually multiply it though, right? Divide by x, divide by x. We got rid of that. Next thing we're going to do is get rid of the 2 minus 2 minus 2. So the inverse, g to the negative first of x, should be 4 over x minus 2. All right, so this tells me this is like a bunch of parentheses. Remember open circle? So I want 4 divided by 0 minus 2. Let's see, 4 divided by 0. Oh no, it's the end of the universe. We can't do this, right? That's undefined. Or we might say no solution to it. But what if we did this the other way around? So now it's g of 0. Well, that was this one. So 4, in place of x, I put in 0 plus 2. Well, that's 4 over 2. That's just 2. Can I put 2 into the inverse? Sure, 4 over 2 minus 2. 4 over 2 is 2. 2 minus 2 is 0. Okay, so I get an answer of 0 this time. Remember, we weren't proving that they were inverses. We were just trying to solve these 2 extra problems. And if I want to prove it, I plug the function into the original. All right, so we got some fun things to do down here. We'll assign those in class. If you're not in my class and you want to try them out, then I guess screenshot it. I don't know, 2042 or something, some number I made up earlier today. All right. Hey, thanks for watching. Peace.